This is a final exam from my past course, and it's basically given like this. You're given a title page, and there is the questions, and pretty much similar type questions. Provide a systematic name for the following compounds. Here's the formula, and you're supposed to give the name. Now, if you don't know the name of the elements or the polyatomic anions, then there is the common ion table that's at the very back. This is your data sheet. Here's barium. Barium is 2 plus. There is fluoride. So when you're naming ionic compounds that are from the first column, group 1, group 2, or aluminum, they don't have any Roman numerals or multiplicity prefixes because there's only one way to name these compounds. So this is just barium fluoride. So remember the monoatomic ions, the ones that have only one type of elements, the monoatomic anions, we have an IDE ending. You have to remember IDE. Okay, so this is barium fluoride. The next one, you'll find that copper is found in group 3 to 12. This is a transition metal, so you need to find the charge on the copper. And again, what you need to do is you need to visit the common ion table. If you cannot remember the ions, here is copper 1 and copper 2, and notice that there's a Roman numeral to this. So Roman numeral for copper 2 and copper 1 has a Roman numeral 1. Now, carbonate. Okay, well, go to your ion table, the anions. There's CO3 right here. It's called carbonate, CO3 2 minus. That means copper is copper 2 plus. So now we're just gonna slide this over. This is copper. This should be easy. It's copper 2, and we call this carbonate. The last one, again, if you don't know this potassium, okay, we'll go to the common ion table. You need to always refer to this data table, and we look for K plus is potassium, and ClO3. Whenever you have oxygen, oxygen is bound to another element, and so you just gotta peruse the table and look for it. It's right here, chlorate, ClO3, and that would be a potassium, K plus with ClO3 minus. And again, just gonna push this over. Okay, so this is potassium chlorate. So make sure you use that common ion table. Also, remember that group 3 to group 12, column 3 to 12 are transition metals. They need a Roman numeral. Some of the other elements to the right of the group 12 also needs a Roman numeral, and you could see it in the common ion table. Here is a series of them. Again, go to the common ion table and you'll find these names there. So for example, an acetate. What is an acetate? If you don't know an acetate, go to the common ion table. And from the common ion table, you'll see acetate. Oh, there it is. It's a CH3CO2 minus. So that means that that will be bound to lead. Okay, so let's take a look at lead. Lead, so you can't remember the symbol for lead. Oops. Where did that come out? Okay. Lead, 4 acetate. You go to the common ion table. Here it is. Lead 4, Pb4 right here. How many acetates do you need to balance that? There's only a negative charge on the acetate. And so that negative charge on the acetate will tell you that this is going to require Pb is lead. So you write down Pb and then CH3 CO2, CH3CO2 with a negative, we get rid of the negative charge and put a 4 here to balance this out. And this is lead 4 acetate. And it's just basically copying things from the common ion table. Calcium oxalate. Okay, let's take a look at calcium oxalate from that table. Where can we find oxalate alphabetic order? C2O4 2-. So calcium is right here. The C2O4 oxalate, C2O4 is right there. So this is how you can master this section on this table. So we're going to go calcium C2O4. And this is the calcium oxalate. For the nonmetals to nonmetals, notice that there's multiplicity prefixes. For the first element of that set, there's no multiplicity prefixes, so there's no mono required. This is just N, NO2, nitrogen dioxide, which is a brown gas. There you go. That is for the naming, quite easy. Remember, multiplicity prefixes only for the nonmetals to nonmetals. This is on the right side of the periodic table. Now, it says provide the chemical formula for a missing acid or conjugate base. Whenever you have a conjugate base, it's always a negative charge, or if there's no negative charge, that means that we're going to add a proton. So let's take a look at this. So we're going to add a proton, H plus, to this. So H plus with a ClO4 minus, that means it becomes a neutral compound, HClO4. And this one, we add a hydrogen H plus to HC, the bicarbonate ion. It's called a bicarbonate, hydrogen carbonate. So the hydrogen carbonate becomes H2CO3 because we're adding an H plus, so it neutralizes the negative charge. For the acid HSO4 minus, we take away a proton, so H plus is removed. We're going to increase the negative charge. So negative charge becomes SO4 2- for the sulfate ion. Again, if you're in doubt, please check the common ion table for these ions. Okay? The nuclear symbol is represented by A over Z. E is for the element. Z is the proton number that identifies the element, and A is the atomic mass. All these numbers in this table have to be whole numbers. So you need the periodic table. In the periodic table, this number might be a little bit different for tungsten. You need to check the periodic table. See if I could expand it a little bit. So you're looking for tungsten. Where can you find tungsten? So it's going to be a treasure hunt for you because you are not familiar with these elements. So tungsten would be a transition metal. It's right here. Notice that says 183.84. Now that is the average atomic mass. And because tungsten has different kinds of isotopes, which are different number of neutrons present in that atom. Okay, so it's an average. So what we got here, let's going to push this over. So tungsten, as you remember, is 183.84, but it says 185. Now don't get confused with this because this is basically the isotope of that element. Now, number of atomic mass is automatically 185. It's nothing else. It's a whole number. And what we now have to put in, let's take a look at what's the rest of it. The number of protons is given on the periodic table. So as you can see in the periodic table, the number 74 above, that is the atomic number. The atomic number is 74. That means 74 protons. Okay, now to find the number of neutrons, we normally put the 74 underneath the 185, and you do a quick calculation, 185 minus 74. gives you 111. The number of neutrons. Again, this is one of the isotopes. Now, the number of electrons and the protons will be exactly the same because, as you could see in our symbol, there is no charge.